Oi, gente, boa tarde. Então, a gente está no último dia de evento. Espero que vocês estejam gostando. Hoje a gente ainda tem mais 2 atividades fora essa. Então, espero que vocês curtam as atividades. Hoje a gente está aqui com a professora Zlat e a gente vai começar. Já já ela vai apresentar e depois a gente vai ter um tempo para perguntas. Então, só lembrando vocês de novo que todas as atividades têm a lista de presença. Então, a gente coloca a lista de presença nos comentários. E aí, lembrem de assinar, porque quando a atividade acaba, a gente fecha essa lista. E vocês podem colocar as suas perguntas, comentários, nos comentários do YouTube. E aí a gente vai ter um tempo para discutir e para responder no final. Ok. Bom, eu vou apresentar a professora e aí depois eu já passo a palavra. So, she's a postdoctoral researcher in the Department of Psychology of the University of York, where she works on a multi-study longitudinal project investigating bilingual language control in healthy aging and aging with mild cognitive impairments, supervised by Dr. Angela De Bruin. She's also a teaching fellow at the School of Psychology, University of Birmingham. Previously, she was a postdoctoral fellow at the School of Psychology, University of Nottingham, working with Dr. Ji-Young Young. She finished her PhD in the School of Psychology, University of Birmingham. Her 2 superhero supervisors were Professor Andrea Crott and Dr. Ali Mazarari. Her research interests include bi- or multilingualism as a possible cognitive brain protective lifelong experience, dementia and health aging, cognitive control, language control, brain functioning, and structure in healthy adults and in dementia. She's also very passionate about open scholarship and doing and teaching better science. She's also a fellow of the Higher Education Academy. So, thank you so much, Professor, for being here. And now I'm leaving the screen, but I'm still here if you need me.
Thank you so much for your kind introduction words, Alice. Thank you for everyone who comes here. Muito obrigada por me convidar. I will now share my screen and I will start my presentation. And I welcome your questions or suggestions at the end. Okay, I hope you can see my screen now.
Yeah.
Okay.
Can you put it? Yeah.
Yeah.
Yeah, now it's okay.
It is taking its time. So I will tell you today about 2 different projects that are all about language control and the role of individual differences and brain function in it. The first part of this presentation, I'll talk about reactive and proactive language control, and I'll explain a little bit about what that is in language switching. So we're going to look at ERPs, oscillations, and individual differences. And this is work I did as part of my PhD at the University of Birmingham. So imagine a situation where you are living in an English-speaking country like the UK, but at home you speak Portuguese with your family. In this case, theory says that you will have to keep one language separate from the other, or you will have to, in any moment of time, know which language to inhibit or suppress, such that you can select the right language with the right person and you don't mix up. And one of the most important frameworks that explains the process of language switching is the inhibitory control model, which says exactly this, that languages are always active and they always compete which language will be selected for production. And what the bilingual needs to do is to exercise inhibition on the right language at the right moment in two separate steps. First, they need to exercise inhibition at the global level, where they select the language itself, and then they need to exercise inhibition at the local level when they select the specific words for production or specific lexical item. We call these lemma or lexical representation. So over here you can see some example of a language switching paradigm picture naming, where people here first see a cue, which language they need to produce, and later on they see the actual picture where they need to extract the specific lemma or lexical representation to say turtle or the correspondence of that in Dutch. So what happens when people switch language further? When they inhibit one or the other language, this is a costly process and it requires a lot of control and a lot of cognitive effort. So sometimes we notice something called asymmetric language switching costs, which is more difficult and slower switching back into the language that is stronger. So for example, imagine a person who's native speaker in Spanish, but has learned English later on in life, and they have to speak Spanish. Then they have to inhibit Spanish, go to English, their second language, and then they have to return back to Spanish, their dominant language. So this return back to Spanish is more difficult and more costly than if they would be switching to English. This seems a bit counterintuitive because Spanish is the dominant language. Why would that be the case? But the context is that your more dominant language is stronger and it needs a lot of inhibition. So when you need to reactivate it later on, you need to exert yet bigger activation to surpass your previous inhibition. So that's why this asymmetric switching costs happen. And this is noticed in the accuracy of the response and the response time. But when does this happen actually? Different studies say that this happens at the part where people have to select the whole language, that is the global level, or at the part when they select the specific local lemma, lexical representation, or even at both. So can we disentangle this process is the question. Where do these switching costs exactly happen? Now, one of the problems with disentangling this is that there are all sorts of different paradigms out there, structured in a different way. Sometimes the cue and this target might appear at the same time. Sometimes, just like here, they might appear one in preceding the other. And there are all sorts of ways how this is structured in terms of the time between the presentations and so on and so forth. So this produces a variety and a diversity of findings, and also there's a diversity of bilingual speakers with their individual different characteristics taking part in these experiments. So you can probably see where I'm going with it. The results are quite dependent on these individual characteristics and on the paradigm. Overall, we know something very generic about what happens in the brain when people get to these different stages of schema and lemma process of language switching. So what we know so far is at the stage of the cue, where supposedly people activate the whole language or the schema, they demonstrate in terms of the event-related potential in the EEG, proactive control or proactive responses, such that an N2 or late positive component, which both are related to proactive inhibition, to activation of semantic meaning, etc. Further down the line, when they are supposed to be selecting over here where you see the turtle, they're supposed to be selecting the specific lexical item. So there we notice another N2, which is a different marker for reactive inhibition. And a different late positive component. So there is also some semantic extraction and semantic inhibition here, but it's a reactive process because this is what the brain is doing. It's integrating the cue, the stimulus with the response it needs to do. So this is the part where participants respond. They don't really do anything at the cue. And also an N400, which is a marker of lexical availability, is also noticed there in the ERPs. What about the oscillation? Because this is the other part of my presentation. Well, that's actually a very understudied topic when it comes to picture naming language switching. There's only at the moment 4 studies of that published. But all of them, they're interested in 2 main bands of oscillations, theta and alpha, more specifically mid-frontal theta and alpha. So theta is a marker of proactive inhibition, working memory activation, reallocation of control and attention. And it is very much related to alpha in a way in which connected vessels are created. So that is theta is a process that redirects alpha, and alpha is a reactive inhibition process. So in a way, mid-frontal theta, successfully exercised, can activate posterior alpha, which is the inhibitory mechanism in the brain. So we expect to see these. We expected to see these 2 activities in our results as related and working together processes. Now, what about the individual differences that can affect the asymmetric switching cost? There is a number of them noted in the literature that are discussed to have affected asymmetric switching, such as the proficiency balance between the 2 languages, or how much more proficient one language is compared to the other, the switching behaviors and communicative interactional contexts that participants take part in habitually in their daily life, how much they use the language, and in how many different varieties of context. And one of these very important ideas is expressed in the adaptive control hypothesis, which says that there are 3 main types of interactional environments. A single language environment would mean something like the initial picture I showed you, where you speak one language at home, let's say Portuguese, and another language outside of the home, and you never mix them, and they never meet, these 2 languages. A dual language environment would be if you work in a place where some people only speak English and other people only speak Portuguese, and you have to change the language and switch between the different people. But overall, you'll keep one person, one language, or one conversation, one language. And finally, dense code switching happens in societies where the 2 languages coexist together. Think about India, or think about Macau, where 2 languages are constantly used at the same time, and you can say one sentence using words from both. There's other models like the UBET model, which talks about the diversity and intensity of language use. So the more diversity and intensity you use your languages throughout your life, the stronger your proactive control is, and the less you rely on reactive control. The longer you are bilingual, same thing, the better proactive control, because reactive control is something that we use in the initial stages when we acquire a language, when we need to consciously monitor the output that we produce in one or the other languages. And of course, the more balanced you are in your proficiency, the better inhibitor you should be, or that's at least what the model says. So what do we take out of all these tons of theoretical models? The inhibitory control model says that inhibition is used to first select a language schema, or the whole language, and then the lemma, the lexical representation, where the e.g. suggests that schema will be related to proactive control and lemma to reactive control. So proactive follows reactive. And the adaptive control hypothesis says that proactive and reactive control are both trained by the demands of these three interactional contexts that I showed you. And finally, the UBET model goes further to say that there are some other practices in individual bilingual experiences that will train executive control and likely may make your proactive control better and make you rely less on reactive control. So from here, we pose first the question. Now, are reactive and proactive control involved in the way that the theory says consecutively, and how are they involved in language switching when people have to name a picture? And we'll address this using behavior results, event-related potential, and also oscillations to respond to this gap in research of the lack of studies with oscillation. And the research question too, can the individual bilingual experiences that the theories talk about explain the switching costs that have been found? There is also a research gap here, which is the continuous link between language experiences, predicting neurofunctioning, predicting language control. For this, we tested 89 highly proficient, rather unbalanced, but very proficient in both languages, bilinguals. They spoke the languages that you see below in English and were living at that time in the UK. 84 of them also have taken part in a questionnaire, which produced the individual difference factors for the study. We gave them a picture naming task similar to the one that you saw earlier in my presentation. We recorded accuracy and response time. So people see this red or blue square here, which is the cue. They're instructed which language is which color for them. And then they see a picture which they name to, over here, have to name in the right language. So that is, language can change from trial to trial, and the type of trial can also change. That can be a switch or a non-switch trial. Let's say if this is followed by a blue square afterwards, then that will be a switch trial for them. We recorded the 64 channel EEGs. What you're going to see is an average reference. And then people filled out this language experience and switching behavior questionnaire. So part one is the EEG experiment. We have the response time and accuracy data. We have the evoked activity, that is ERP, and the induced activity, which is the oscillation in theta and alpha range. We expect to see asymmetric switching cost and the markers of proactive control schema and reactive control target. How we analyze this, we looked at two different analyses, two factors in our analysis, switching. In the switching factor, we compared conditions in the same language, such as L1 switch versus L1 non-switch. And in the language, for the language factor, we compared across language. So L1 switch to L2 switch. Oops. The behavior analysis, we did mixed models, and we did cluster-based permutations for the EEG. Well, we found behaviorally for accuracy, people are less accurate when switching, but it didn't matter towards which language they're switching. So no difference in performance between L1 and L2. But they're also slower when switching and slower in general when naming in L1 overall. So that's a global slowing of L1 effect, which has been previously found. And L1 switching was slower than L2 switching. So this is exactly the asymmetric switching cost, which we found in the response time here. For the EEG data, this is a bit, mind you, so I'll try and unpack it a little bit to be clearer. We did 4 different analyses. So for the ERPs, which I'm going to show you first, we looked at a time interval from the start of the cue to a second after. And for the target, we looked from the start of the target to 2 seconds after. That was the response window for people. For the TFRs, we always looked at a 1.5 second time interval in both cases for cue and for target. Now, first, I'm going to show you what the ERPs looked like when people saw the queue. Sorry, that might be a bit blurred on your screen. So when the queue appeared, in the different comparisons, we only saw a significant difference when we looked at the switching factor. So when we compared L1 switch to L1 non-switch and L2 switch to L2 non-switch, we didn't find any significant difference for the language factor. That is when we compared L1 switch to L2 switch and so forth. And here the components or the ERPs the effect that we saw were very similar between the two languages, very similar in timing, in location. Overall, this is a component, this anterior negativity, posterior positivity complex is something that is very commonly found in task switching, non-verbal tasks, such as color shape switching or number letter switching, if we argue that number letter is non-verbal, of course. And this is some sort of an initial task set reconfiguration processes so that the brain can extract from the working memory the right types of responses for the cue that it's given. Now, here at the target, what we found, we found the opposite thing. We did not find anything when we compared the switch for the switching factor, L1 switch to L1 non-switch, neither for L2. But we combined together, merged across language, just the switching versus the non-switching. And there we saw something like a higher center of positivity for switching compared to non-switching. In this case, this is also something that has been widely found in non-verbal task switching literature, and it's usually understood as a later continuous task set reconfiguration process, like a second stage of task switching, where you continuously reevaluate the right response to the cue and the target that you're given. So some sort of follow-up integrational processes. And it is interesting because they don't stop, these processes don't stop when the target appears, but they seem to continue alongside something else. And what else we found is when we compared for the switching, for the language factor, we found different effects when people are switching and when we compare L2 to L1, and when people are not switching, continuing in the same language. So when they're switching, L2 showed these two higher central positivities. When people are not switching, L2 showed this stronger occipital negativity. And this positivity here is actually a late positive component, which usually is lower for the less lexically available language. So what that is when people are switching into L1, that is the language that is less lexically available, which is expected because that aligns with the asymmetric switching cost, or the higher difficulty to switch into L1. And these later effects that you see here and here are likely related to continuous processes of alignment of the stimulus and the plant response, and particularly for the non-switching, for the time where this appears, this is likely related to more difficulty in motor response preparation for the less dominant language. So when people have to switch, initial preparation is more difficult to extract the semantics in the dominant language. But once they do that, production seems to be requiring more in the non-dominant language. Now, for the time frequency response or the oscillations, we didn't find any significant differences at target, so I will only show you what we found at the cue. At the cue, we found stronger alpha suppression induced by switching only for L1, but not for L2. So you can see this very broadly distributed central posterior alpha suppression, which means that people, when they have to switch, they exercise a lot more they suppress stronger their alpha, and alpha is a mark of inhibition. So that is when they switch, they require a lot more inhibition. And this makes sense a lot because switching is more difficult than staying in the same language. But we only see this effect for L1. Unlike when we looked at the ERPs earlier, we saw similar effects for L1 and L2, but the oscillation seems to be adding a different layer of explanation to the results and offering explanations that ERPs only cannot provide by themselves. So in short, at the Q, we saw proactive control at the schema, which was in the ERPs, but only for the oscillations, we saw inhibitory induced activity, which was specifically for L1, only in the oscillations. At the schema, it seems that these proactive control preparations continue in parallel with the lemma selection reactive processes. So these processes don't stop when the target appears, but they continue simultaneously. And when we looked at the target, switching, when people have to switch, preparation in L1 is more difficult to extract the right lexical element. But after this is done, speech planning is more difficult in the other language, which is less proficient. So what can individual differences explain about these findings that we found? And do these findings and these abilities of the bilingual to apply inhibition depend on the individual differences in any way? That is the question we ask, whether bilingual experiences can explain our switching cost, both neurally and behaviorally. For this, we use the Switching Experience and Environment Questionnaire. You can grab it from the QR code along with a guide on how to use it and how to pre-process and analyze the data. And our expectations were that the intensity of the language use and the diversity will predict better proactive control. So higher intensity, higher diversity, better proactive control. The longer people are bilingual, they will be better in their efficiency to select one language or the other. So maybe switching costs will be smaller. And finally, the more balanced they are between the proficiency of their two languages, the better inhibition overall and efficiency they will show. And also we expect, according to the adaptive control hypothesis, where I showed you the 3 different contexts, that cognitive control will be trained and inhibition will be improved the more they do dual, particularly dual language contexts, where they have to suppress one language to address different people with different language. So how we analyze this? We first performed a confirmatory factor analysis to extract the individual difference factors from the questionnaire, and then use these individual different factors, the EEG cost, which is just the subtraction between switch and non-switch for each language, and the subtraction of the switch and non-switch for the response time between the two languages. And we built a model in the sense that individual experiences predicting brain functioning, predicting behavior. This confirmatory factor analysis that we did converged with 3 factors. One is a combination of of the proficiency or dominance of the language and how long people are bilinguals. The other contains dense code switching. And finally, the 3rd factor contains dual language environment behaviors. And this is a very complex model, but I'll now explain it for you. On the top here, you can see the first levels of the factors that we extracted from the questionnaire, the 3 factors that I just mentioned. Basically, these all loaded onto these latent variables executive function demands, which we expect that these types of behaviors will train, and efficiency, which we expect that this diversity of use and intensity, dominance will train, and they're all loaded. And then these latent variables, we expect that they would predict either the induced neurofunctioning costs or the evoked neurofunctioning cost. In the induced, we had the significant alpha suppression effect for L1, and in the evoked, we had the switching costs in the ERPs at the time of the Q. So this is all at the time of the Q. Now, what we found is that executive function demands seem to predict alpha suppression. So in a way, these behaviors that people did, if they did more of dual and dense code switching, this predicted kind of their ability to exercise stronger alpha suppression. Unfortunately, this relationship from neural costs then predicting behavioral switching costs did not show any significance. So we can't really make any sort of conclusions of what this means for the behavior. On the other hand, though, efficiency didn't really predict the evoked costs, but the evoked costs themselves seem to be guiding the L2 switching cost only. That is, the bigger the switching costs in the dominant language, the bigger the effort people exercise to switch in the dominant language and the less effort they exercise switching in the second language, the worse they perform in the second language, which kind of makes sense because then L1, their dominant language, is more activated. So what's the take-home message? Different neural procedures, there are different neural procedures at language schema and language lemma driving the switching cost to some degree, but these also partially coincide. And we do see actually proactive control at the schema and reactive control at the lemma, as it was suggested, even though they can coincide and they can happen somewhat simultaneously. And then individual bilingual experiences explain the switching costs mediated by the neural control. Not really, not conclusively. To some degree, we saw some sort of a link between individual difference factors like dual language environment and dense code switching, predicting alpha suppression. But then this relationship between alpha suppression and behavior cost did not show any significance. And we also found this partial link that it seems the behavioral costs in the second language were explained by the ERPs, ERP costs particularly. It is possible that there is no link in the first place between individual differences and language switching costs in the first place. That is a possibility in the real world. It's also possible that we didn't have enough power to explain this complex model that we built. And due to the lack of power, we chunked a lot of variables into the predictors from the questionnaire into those factors. So maybe it's a too crude of a measure for individual differences. We don't know that, but we keep trying. So the next part of my presentation that I'll talk about is related to my current work. For some reason, despite not finding what I expected to find, I keep not giving up, and I keep revisiting these individual differences in language control, and this time from the perspective of aging. So how does that affect our language control when we age? That's part of a large 5-year longitudinal project called Multi-Age, Multilingualism and Aging, which I'm a postdoc on at the University of York, and I work with Dr. Farah Nazir and Dr. Angela De Bruyn. Multi-Age or Multilingualism and Aging project consists of 4 different projects within itself. You can look at the website using the QR code if you want to know more details about the project itself. But overall, the different work packages aim to understand how language control and change throughout the generations, so between young and old speakers, but also how they change affected by individual difference and usage patterns. And then usage patterns themselves, how are they affected with this transitions from youth to late adulthood. And finally, last part of the project, which is the fourth work package that you see here, asks how these changes are affected by healthy aging and aging with mild cognitive impairment. So that is kind of considered a preclinical dementia stage. The first work package particularly looks at language control and usage with aging, and that is what I'll talk to you today more about. The second one looks at individual differences, which we are currently preparing. The third one looks at how the characteristics of the speaker that you're interacting with, their age, their gender, how proficient they are in different languages, which language they prefer to use, what is their social status. So things like that, how they can affect your choice of language and your choice to switch or not to switch language. The rationale of this project is very wide and is related both to aging and to control and particular status of the languages. We know that the population in the world is aging rapidly, and we know from monolingual research on aging and language that certain abilities with language change with age for us. For example, people might experience more tip of the tongue events where they can almost remember a word. They know what they want to say, but they can't seem to be able to find the right word. It's at the tip of their tongue, we say. So these things happen more often. People might struggle with extracting the semantics. People might struggle with building certain more complex grammatical structures later on. But all of this research anyways is done on monolinguals. So we don't know what happens in bilingual speakers. And a bilingual is not just two monolinguals in one body. It's a completely different entity, and it's a completely different way of using and controlling language. And it's even more interesting question what happens when people are speakers of a minority language. So there is some research, for example, with people who speak a minority language and who have retired in a different country. But that group of people are usually very different. When you retire and you go to live somewhere else using your language, that's a very different situation from being a minority within the country that you inhabit. And what is more interesting, the people that we are looking at, they're speakers of a continuum of languages called Pahari or Potwari and Punjabi or Punjabi and English. These people are roughly more than 2/3 of the Pakistani diaspora in the UK, and yet Pahari Potwari language continuum is not an officially recognized language. So if your child, for example, studies at school and needs some language support, if you are asked what language you speak at home, you're usually given a form where you fill out, you tick the right language that your child and you speak. Pahari Potwari doesn't exist in that form because for the UK government, Pahari Potwari is not an existing language. So that creates further specific factors in the status of the language and in how bilinguals can use it. If your language is considered unofficial, then maybe you're more restricted to when you can switch, who you can use it with, etc. And finally, language control is studied quite a lot in dual language switching tasks, just like the one I showed you, where people need to switch between languages, name pictures or say sentences, or do some sort of decisions in one or the other language. We know that language control, reactive and proactive control, separately, change during aging, but the findings are quite controversial and also very limited. So some studies find that reactive control in certain situations worsens with aging. Other people find worse proactive control. And also there are studies that don't find any difference or find a decline in both. So we don't really know what's happening with reactive and proactive control. And we just saw that they're quite important because they are part of a whole process of language switching, and they have different roles at different stages of this language switching. And finally, all of this research that I just told you about now in the slide has been done with usually isolated single word production experiments. So people have to say a picture or select a picture or select a word. There is very little research done in connected speech. So we don't know whether what we found is even going to be holding water if we look at connected speech. And that is part of the aims of this project, to look at minority language speakers of heritage language where the language is not officially recognized, to look at aging, to look at dual language context, and to look at that in connected speech. Particularly, in this first part of the project that we are now working on, we are interested in how reactive and proactive control during dual language context differ between young and old bilingual adults from the community we are testing. And also we're interested how language control and any age group differences are modulated by the specific switching context. So this is related back to the first part of my presentation where I talked about single language context, dual language context, and dense code switching. And we want to know particularly whether switching changes when it is in response to a cue and when it is voluntarily, where voluntary cue switching is supposed to imitate a little bit better dense code switching, while cued is supposed to mimic rather dual language context. And further here, research has found that when it is down to voluntary switching, some of the age differences and age costs in switching might reduce or disappear. And to address this idea of looking at language in connected speech, we are using a scene description task in addition to the picture naming task. In this scene description task, people have to produce sentences in a single language based on a cue that they see, in a single language based on their own voluntary choice, or in a single language by voluntary choice, but with allowed switching within the sentence. And to record people's individual differences, we have some additional tasks such as a questionnaire or a conglomerate of different questionnaires, a fluency interview, and a narrative task which records more naturalistically people's language switching behavior in connected speech. This is a generic summary of the two main tasks of the study, the picture naming. So you can see the cue is a face of a person. You can't see the face here because it's unfortunately from a database where I'm not allowed to display people's faces. But imagine that these two blue icons here are a male and a female speaker of the people's home language. And the red ones are a native speaker of English, and people are asked to say the words in the right language. So that's when they're cued. When they do voluntary switching, they get only two speakers for whom they instructed that those people speak any language, any of the two languages they use, and they're pretty fluent in both. So it is up to the participants to choose which language they want to use. So you can see people saying, people can choose to say seb or apple, mombati or candle, and so on and so forth. In the scene description task, the principle is the same, but people produce sentences which is a more naturalistic way to measure language switching, and also allows us to look at other factors such as pauses between the words, frequency of the produced response, how many times they switch in a sentence, when do they switch, yeah, and all other syntactic, semantic, etc. Variables that you can include when you have a sentence. So when they are in the queued same context, they are told by the face icon which language to use, and then they have to produce the sentence in that language only. In the voluntary one, they can choose, but they are constrained once choosing the language to continue producing in that language and not mix. So if they choose here English, they have to say a cat is chasing a mouse, or the Bahari version, but they can't mix words. And then finally, in the voluntary context, they can produce sentences such as "E mora football now cair nai," where they mix both languages. Here they use football from English, or you can shopping from English in this one, and so on. So these different contexts are supposed to mimic closely the adaptive control hypothesis context, while allowing for voluntary in-queue switching to test how language control changes with age and how it changes for a group of people across different contexts. How do we test for this project? We are currently running testing. We've got about 60 participants, and we are looking for 240, so almost there. We're looking for young adults between 18 and 30, and older between 62 and 74. And they are speakers of Pahari Potwari, also called Mirpuri by some communities, or Punjabi, and English. And these are neurologically and psychiatrically healthy people with normal vision and hearing and incapacity to give participation. At this point, we exclude any cognitive impairment, major head trauma, loss of consciousness, so on, medication affecting alertness, and too low proficiency to complete the tasks. And the reason why we exclude so many medical conditions is because part of the project, that is the last part where we look at cognitive impairment, is going to use a functional near-infrared spectroscopy as a method to track brain functioning during the sentence production task. We are also hoping to be able to apply that in our current work package, one that you see here. And I'm setting up the equipment, so wish me good luck. Hopefully this is going to work. And finally, I will give you a very brief overview of some very preliminary trends in findings. This is about 20 people or so that we've analyzed pre-processed data. So it's very, very, very generic. We haven't yet gotten to analyzing the rest of the data. But you can see reaction time trends and task context. So this is for the language switching picture naming task, where people have to produce a single word to name a single picture or a single item on a picture. So you see that switching in queued contexts seems to be the most difficult, while voluntary language usage, and particularly even switching, seems to be kind of easier than single language. And it's a very interesting concept because that's what previous research has found as well, some of it by Angelo De Bruyn, or some of it by other people. And also this community that we're testing, they're characterized by this particular dense code switching behaviors where they use both languages in the same sentence at the same time. So constraining these people to a single language is almost an effort for them, because that's not how they usually speak. But also that allows people to extract the right word quickly, regardless of the language, and use whatever is available first to their mind. So this is what we found so far. we're very, very early stage of testing and analyzing data, pre-processing data. I'm happy to answer more questions in terms of the future development of this project. Finally, muito obrigada, perguntas. And you have my contacts as well if you want to get in touch. And these are the amazing people that I worked with during my PhD, Dr. Andrea Crow, Dr. Ari Mazahir, my supervisors, Dr. Felix Carter, and Dr. Vince De Luca, the postdocs on the project, Dr. Consuelo, the research assistant, and finally, my current supervisor, Dr. Angela De Bruyn, and my colleague, Dr. Farah Nazir. And thank you to the two universities and the research bodies that funded all this research. Thank you very much. That is all from me. I'm happy to take any questions.
Do you hear me?
Yes, I can hear you.
Okay, so thank you so much for your talk. We have a question here on comments. I'll put it on screen so you can see it too.
Okay, do the type of code switching produced more frequently by the speaker play a role? And what are your thoughts on that? Yes, I know what you're thinking about. Yes, very good question. Thank you so much. You're thinking about the more fine classifications of code switching, such as like dense code switching, lexicalizations, and all these types of code switches, most probably. So yes, in a way, for the first study, we haven't distinguished about more finely between these types of code switching. So the findings that you saw in the structural equation model, where dense code switching predicts alpha suppression, this is any sort of dense code switching. And then I say dense code switching as a group of code switches within the same sentence. So people are not, when they filled in the questionnaire, they were not particularly instructed what type of code switching. They were just told that some people switch within the same sentence, and then they were given an example of a sentence in English with a word in another language in it. So like an insertion. So in a way, it may be possible that this primed people to think about insertions. And what I see here is actually results about these specific insertions, as opposed to any other type of code switching. I'm not able to say that because I haven't distinguished them. But I think that it will influence it. And in the last part of the presentation, so in the current study that we're doing, we will be able to look at this more finely, particularly in the sentence production task, because there we can see what people say, and we can see what people normally produce. So we know what type of code switches they refer to. But in a questionnaire, it's a bit tricky to distinguish it, I guess. It's we have some examples of what people might do in the questionnaire, but mostly people are not usually aware of the different type of code switch when they do. People do it, at least our participants, they do it unconsciously. So they're not necessarily able to tell them apart if asked in a question. So yeah, I hope that answers your questions, but please feel free to add more information.
Thank you. I have something to ask. It's actually a doubt I had. You said that you didn't find yet a link between individual differences and inhibition cost. That's it?
Yeah, so in order for me to say that I found the link, I should be able to say how, or kind of in my mind, I should be able to say how this affects behavior. So the link should start from the individual difference and affect somehow the neural processes. and then from these neural process predict the behavioral cost. But if I'm not predicting the behavior cost, I don't know if the magnitude of this effect is big enough to actually change behavior. So in a way, you can exercise more stronger alpha suppression. And this might mean that you're a better inhibitor and you get smaller switching costs in your behavior. But it is possible that you exercise stronger alpha to compensate for the fact that you're not able to perform that well in your behavior. So both types of exits of the situation are possible. So in order for me to say, yes, individual differences do affect behaviorally how people function, the actual what they produce and the cost of what they produce, I would need to see this continuous link between the three levels. So far, I can only say that they seem to be exercising stronger alpha suppression when in the situations that they do more of dense code switching and dual language behaviors in their daily life. But I don't know how that affects their behavior. That makes sense.
Yeah, I was curious about this, about your hypothesis, because I was thinking if dense code switching environment would be linked to more cost or less cost, because people did more code switching, but they would be more used to do it. So the hypothesis was that it would have bigger cost. That's it.
So the idea is that the more you train, particularly dense code switching, the more you do this kind of engage in this kind of behaviors, the more you train your inhibitory control abilities. And as you go along doing this behavior and training these abilities of yours, you should be able to harness these cognitive inhibitory control abilities and apply them when you switch language and be better in it in a way. But I can't say if we are better or not in this case, because there's no link to the behavioral outcome. And this is where you can actually see the magnitude of the difference in the real world.
Yeah. It's interesting. Thank you. We have another question from Guilherme. I'll put it here.
Would it be possible to find the relationship between the interactional context and cognitive reserve? Proactive control in HB interact with their habits of switching. That is possible, actually. One of the ideas of the cognitive reserve is that you use language behavior, so language switching, and it affects how you train your cognition, and that maybe provides some sort of a reserve for you to later on compensate for any cognitive decline. In this sense, we won't be testing people's generic cognitive control abilities, such as nonverbal switching inhibition and attention redirection. We will only be testing their language control. Why? Because we were scared of this debate. No, we weren't scared, but it's a big debate whether language control and cognitive control are the same thing and they're governed by the same principles, or they're completely different, or they partially overlap. So we will only be looking at language switching, but we do expect to see that certain types of behaviors might, let's say, benefit people when it comes to their behavioral performance in proactive control or in reactive control. So we have, for this last part of the project, we're looking at the switching costs. So that's the difference when you switch to when you not switch in a block where you're using both languages, and mixing costs, which is the difference to using Portuguese when you have a block of only Portuguese, and using Portuguese when you have a block of Portuguese and English. So we are hoping that this latter one, the mixing cost, which is usually a proactive control measure, would actually be affected by individual differences, such as some type of dual language switching or particular use of language. There's lots of different things we're looking at, how they use the languages in their early life throughout, who they use them with, when they switch, how they switch, do they switch intentionally or not, do they switch in the sentence, between sentence, yeah, lots of stuff going on. So I'm hoping that we find something interesting.
Yeah. So there was a thing I was so curious about. In the ending of your presentation, you showed response time, and it seemed it was easily to switch to voluntary switch than to
stay in the same language.
Yeah. So we can think about a cost too. So it's like the switching cost doesn't appear only when we switch, but sometimes when bilinguals don't switch. It's interesting.
Yeah, in a way, so for this one I can't, we don't, it's just a trend, so we can't see how big is the difference between switch and non-switch within voluntary or within queued. The difference might be very small when we get the results, or might be big enough to be a switching cost. But a lot of people talk about sometimes things like mixing benefit, for example. Especially in the context of aging, where people seem to perform better in a certain language when they are allowed to use it voluntarily in a context of two languages than when they have to be constrained. And one of the specificities of this community that we're testing, which might or might not refer to other communities, that they find it difficult to only use one language for the most part, because that's not how they function. So community is very integrated and they can use both languages. So maybe there is a word, imagine you have to speak and there is a word that is really long in one language, or very culturally specific in the other, or like, I don't know, difficult to pronounce or something like that. You can use any language to say it, but if you're constrained to only one language, then you have to struggle to maintain this one language throughout. So yeah, it seems to be easier in a way so far, but we see when we collect the rest of the data, maybe it will change the direction of the trends.
Yeah, cool. We have another question. Okay, it's for comments, one question, so I'll put it.
Yeah, thank you for it. Okay. Yes, if you think about specific situation that might trigger code switching, I lived in Japan, I got better at switching. Okay. About a month before I returned to Brazil, I started switching very frequently between Japanese and Portuguese, even talking to people who don't speak. Okay. Yeah, so I would assume things like stress or anxiety or even fatigue would affect switching. I don't know much about how factors related to mental health experiences or stress experience or stress responses could affect language switching. But I guess if you start from a more generic account of attentional control, factors like this would affect attentional control, which for whatever task you're doing, whether that is language switching or something else, where you have to manage two processes at the same time, I know driving and talking or anything else that requires you switching between tasks would worsen. So yeah, I guess I hope that answers the questions.
Yeah. And this is also linked to what you said about when a language is how to say it? It's difficult to find the word in another language. But you talked about Pakistan people, and it's different if the language is recognized as a language and not, and perhaps it would be linked also to an anxiety, a type of anxiety to talk your language in another country that doesn't recognize it as a language.
Yeah. And actually, part of the second part of this, if this large project is about is a qualitative study using focus groups, and some of the questions we're going to look at that there is are how the attitudes towards the language from other people and from your own group that you've grown up with and that you currently experience affect your language behaviors. And mind you, for this language, Pahari Potwari, it's not minority just in the UK, it's minority within the Pakistani languages, because there is the national language Urdu, which everybody speaks to some degree if they've studied or lived in Pakistan. And that language is considered the official language, which people should communicate in. So even in comparison, those languages, this continuum of languages are minority. So the minority within the minority as well. So it's very difficult situation linguistically.
Yeah. Thank you. I think we don't have more questions. Let me see in the website. Okay. For those who were watching, lembrem de assinar a lista de presença que eu coloquei aqui nos comentários. Tá fixado. Okay. So, thank you for answering the questions.
Thank you for all your questions. It was very interesting and very engaged discussion with your suggestions.
Yeah. So, thank you, Professor, for being here with us. It was an honor to have you. And we hope you enjoyed the time too with us.
Thank you. Thank you so much for inviting me. It was a real pleasure, and I'm glad to meet you all virtually, and I hope you also enjoyed, and hopefully we meet more in person at some point in the future.
Yeah.
Thank you very much.
Thank you.
And feel free to email me or contact me if you have any questions or suggestions again.
Yeah, thank you so much.
Thank you very much.
Então, pessoal, só para finalizar, a gente está acabando essa atividade, a gente tem outra atividade agora às 4, um seminário às 4, e aí depois a gente tem a palestra de encerramento às 7. Obrigada, pessoal. Até já já.
Enjoy the rest of your day. Bye bye.
Thank you. Bye bye.
Bye.